Today we're on lesson 14 of Unit 10, Polynomial Long Division. We're going to be dividing a polynomial by a polynomial, covering 3 pages, 315 to 317. To divide a polynomial by a polynomial, we'll use a method similar to long division in arithmetic. For example, if let's say we had 2,184, we want to divide that by 18, we would set up long division. We have 18 divides into 2,184, how many times? We say, well, 18 goes into 21 once. Multiply 1 times 18 is 18. Subtract. We get 3. We would bring down the next digit, 8. 18 goes into 38 2 times. 2 times 18, or 2 times 8 is 16, 2 times 1 is 2, plus the 1 left over is 3. Subtract. 38 subtract 36 is 2. We would then bring down the next digit, 4, and 18 into 24 once. 1 times 18 is 18. Subtract. 24 subtract 18 is 6. So we can write this as a remainder of 6 over the divisor, 18. So our answer is, this would be equivalent to 121 with a remainder of, in the 6th 18, so we could reduce to 1/3 with a remainder of 1/3 would be our quotient. So we want to do similar when we have a polynomial being divided by a polynomial. Alright, so we want to divide x squared plus 7x plus 12, which is considered the dividend, by x plus 4. X plus 4 is the divisor. And on this page, we have a detailed step-by-step process that's already worked out for us. So we set it up. X minus 4 divides into x squared plus 7x plus 12. We divide the first term of the dividend, dividing x squared by the first term of the divisor x. X squared divided by x is x, so we place the x above the 7x. And we multiply each term of the divisor by x. X times x is x squared, x times 4 is 4x. Next, surround that result with parentheses and subtract. So we take our x squared plus 4x, put it in parentheses, and subtract. 0, 7x minus 4x is 3x, and then we bring down the next term. And now we divide the first term of the result, of our 3x plus 12. We take 3x and divide it by x. 3x divided by x is 3. We write 3 above the 12. And now we multiply. 3 times x plus 4. 3 times x is 3x. 3 times 4 is positive 12. Wrap that in parentheses. And then subtract. So this, we have no remainder. The remainder in this problem is 0. So the quotient is x plus 3. Now let's practice. Number 1, our dividend is the polynomial consisting of these 4 terms, and our divisor is x plus 4. So setting up our long division, we'll take the first term, 2x to the third, divided by x is 2x squared. We write that above our 5x squared term, and now we multiply. 2x squared times x is 2x cubed. 2x squared times 4 is positive 8x squared. Wrap that in parentheses and put subtraction out in front. Now subtract 2x cubed minus 2x squared is 0. 5x squared minus 8x squared is negative 3x squared. We bring down the next term, minus 7x. Negative 3x squared divided by x is negative 3x. Multiply negative 3x times x plus 4. Negative 3x squared, and negative 3x times the 4, negative 12x. Wrap that in parentheses, put subtraction out in front. Draw your bar. Subtracting negative 3x squared, subtract negative 3x squared is 0. Negative 7x, subtract negative 12x. This becomes negative 7x plus 12x, which is 5x. Bring down the next term, which is the plus 20. 5x divided by x is 5, positive 5. 5 times x is 5x, 5 times 4 is 20, positive 20. Put it in parentheses, subtract, 5x minus 5x is 0, 20 minus 20 is 0. Our quotient is 2x squared minus 3x plus 5, so there is no remainder here. Number 2, we have 3x to the third minus 16x squared minus 72 divided by the binomial x minus 6. Notice that a term is missing. The x term is missing, so we'll need to write 0x as a placeholder. So setting up our long division, x minus 6 divides into 3x cubed minus 16x squared plus 0x minus 72. 3x to the third divided by x is 3x squared. We write that above our negative 16x squared term. Now we multiply. 3x squared times x, 3x cubed. 3x squared times negative 6, negative 18x squared. Wrap it in parentheses, subtract. 3x cubed minus 3x cubed, 0. Negative 16x squared minus negative 18. Negative 16 plus 18 is 2, positive 2x squared. Bring down the next term, the plus 0, x. 2x squared divided by x is 2x. Multiply 2x times x is 2x squared. 2x times negative 6 is negative 12x. Wrap in parentheses and subtract. That's 0. 0x minus negative 12x is 0 plus 12x, which is 12x. Bring down the next term, negative 72. 12x divided by x is 12, positive 12. Now multiply 12 times x minus 6. 12x minus 72. Wrap in parentheses, subtract. Remainder here is 0. So 3x cubed minus 16x squared minus 72 divided by x minus 6 is equivalent to 3x squared plus 2x plus 12. Number 3, these 4 terms are being divided by the binomial 2x minus 4. Let's write out our long division. Our exponents are in descending order 3, 2, 1, 0. So we are not missing any terms. 6x cubed divided by 2x is 3x squared. Now multiply 3x squared times 2x minus 4. 3x squared times 2x, 6x cubed. 3x squared times negative 4, negative 12x squared. Wrap in parentheses, subtraction out in front of the parentheses. 6x cubed minus 6x cubed, 0. Negative 18x squared minus negative 12x squared. So that's negative 18 plus 12, which is negative 6x squared. Bring down the next term, plus 16x. Negative 6x squared divided by 2x is negative 3x. Multiply negative 6x squared plus 12x. Wrap in parentheses and subtract. 0, 16x minus 12x is 4x. Bring down the next term, the minus 4. 4x divided by 2x is 2. Multiply 2 times 2x minus 4 is 4x minus 8. Wrap in parentheses, subtract. 4x minus 4x is 0. Negative 4 minus negative 8, that's negative 4 plus 8, which is positive 4. So we have a remainder of 4 over 2x minus 4, the divisor. Now, this remainder can reduce, right? So let's see. The denominator, the 2x minus 4, is equivalent to 2 times x minus 2. And then the 4 and 2 would reduce. 2 goes into 4 twice. Our answer is simplified 3x squared minus 3x plus 2 plus the remainder of 2 over x minus 2. When we divide two polynomials, we get another polynomial and a remainder. Sometimes that remainder is 0. This is known as writing the rational expression in quotient remainder form. Write each of the following rational expressions in the form q of x plus r over x minus a. In other words, the q of x is simply the quotient, the result, r is the remainder, and the x minus a was our original divisor. Performing our long division, setting up. X squared divided by x is x. Multiply x squared minus 3x. Wrap in parentheses, put the subtraction out in front. 0, 2x minus negative 3x is 2x plus 3x, which would be 5x. Bring down the next term, minus 5. 5x divided by x is 5. Multiply 5 times x, 5x. 5 times negative 3, negative 15. Wrap in parentheses and subtract. 5x minus 5x is 0. Negative 5 minus negative 15, that's negative 5 plus 15 is 10. We want our quotient plus our remainder over our divisor. Our quotient is our x plus 5. Our remainder is 10, so x plus 5 plus 10 over our divisor, x minus 3. This is our answer. (2x squared minus 23x plus 17 divided by x minus 10). (2x squared divided by x is 2x. Multiply 2x squared minus 20x. Wrap in parentheses, subtract. 2x squared minus 2x squared is 0. Negative 23x minus negative 20x. It's negative 23 plus 20 is negative 3x. Bring down the next term, plus 17. Negative 3x divided by x is negative 3. Multiply, negative 3 times x is negative 3x, and negative 3 times negative 10 is positive 30. Wrap in parentheses and subtract. 17 minus 30 is negative 13. Our quotient is our result, our 2x minus 3 plus the remainder, negative 13, over the divisor, x minus 10. And this does not simplify. Alright, and the last thing, this is a little different. Sometimes we can use the structure of an expression instead of polynomial long division. Consider the expression x plus 8 divided by x plus 3. We would like to write this as something plus something over x plus 3. In other words, rewrite the numerator as an equivalent expression involving the expression x plus 3. In other words, so I have this x plus 8 over x plus 3. Well, the numerator x plus 8 I could rewrite as x plus 3 plus 5, right? So I've done is I've taken the 8 and broken it up into 3 plus 5. These are equivalent. Okay, now you see that if I take and group this, then I'm sort of splitting it up, right? Taking x plus 3 over x plus 3 plus 5 over x plus 3. So I just broke up the single fraction into two separate, but yet equivalent. Well, x plus 3 over x plus 3 is equivalent to 1. So this is equal to 1 plus 5 over x plus 3. So in this case, A is 1 and B would be 5. All right, let's try these in number 6. I have this 4x plus 13 divided by x plus 2. Well, I'm thinking to myself, how many x plus 2's do we need to get a 4x? We would need 4x plus 2's. Right? So I'm going to rewrite the 4x plus 13 as 4 times x plus 2. So that's 4x plus 8. But then how much more do we need to bring us to 13? We have 8, so plus 5. And now let's split this up. So we have 4 times x plus 2 over x plus 2 plus 5 over x plus 2. And this reduces. 4, or the x plus 2's divide out, 4 plus 5 over x plus 2. Same thing here. How many x minus 4's will I need to get a 3x? Well, I would need 3x minus 4's to get a 3x. This would be, thinking if I would multiply, that's going to be our 3x minus 12. And what do we have to add to negative 12 so that we end up with the overall minus 5? We would have to add 7. And splitting this up, x minus 4 is here. Divide out. We have 3 plus 7 over x minus 4. And that finishes this lesson. Thank you for your attention.